This is SciByte, episode 82 for February 19th, 2013. Hi everyone, and welcome to another edition of SciByte, Jupiter Broadcasting's weekly science, news, and information podcast. Fresh every Wednesday morning over at jupiterbroadcasting.com and live Tuesday evenings over at jblive.tv. My name is Chris, and joining us every single week is our host, Heather. Hey there, Heather.
Hey there, Chris.
Hey Heather, happy science to you.
Happy science.
All right, what are we talking about today?
Today we're going to take a look at the Russian Meteorite strike, a dark matter announcement, headaches, the asteroid flyby, viewer feedback, an update on CERN, curiosity news, and as always, take a peek back into history and up in the sky this week.
Wow. Big topics for this week's episode. And that meteorite strike, that got so much attention this week. All right, Heather.
Oh, yes.
Let's kick it off with the news. All right, where do we want to begin tonight?
Alrighty. The 2013 meteorite strike. Actually, somebody in the chat room started off saying, what's the difference? Meteor, meteorite. We see all those meteor showers.
Mm-hmm.
A meteorite is when it comes down and when it touches the ground, when it hits the terrestrial Earth. So you got a T for terrestrial there. So this one, now, it kind of exploded above before it hit. It didn't hit in one big chunk.
Yeah.
It exploded into a whole bunch of little chunks and kind of sprayed across around this Russian city.
Yeah, I was just commenting before the show started that we were sort of fortunate that it seems to be a big popular trend for Russian dash cams. So we have tons of really cool footage of like the Russian winter as people are driving around and this massive fireball coming through the sky. And it, Heather, almost looks like something from the movies when you see it.
Yeah, it shone brighter than the sun.
It's amazing.
Yeah, it was quite large. It was above Shelbinsk. All right, I'm going to translate that town as horrible translation. But so if, as you can see from the videos, huge trail left.
Yeah.
It took about 30 seconds. Within about 2 minutes, two huge bangs. So it's traveling through the atmosphere about 30 seconds before it actually broke apart. And the bangs were it going from the sonic booms. And then it had a violent airburst explosion about 12 miles, 20 kilometers or so above the Earth's surface. So any of these, a lot of these asteroids, should I say, there's different types. There's ones that are big iron clumps. There's ones that are just kind of dirt and rock and a whole bunch of stuff melded together, which is what this one was.
Right. Okay.
And when those come through the atmosphere, they burn up. You'll see, smaller ones sometimes. If they're the meteorite showers, then it's a little bit of, ice and dust, all that's put together. And, then you see the little meteor trails.
Mm-hmm.
And then there's sometimes ones that you just sort of out of the blue, you'll see it trail, some sort of meteorite, and it burns up, or occasionally it comes in and you actually get, a chunk of iron that hits. Now, this one specifically was about 55 feet, about 17 meters wide. So it blasts about 500 kilotons, which is mighty. It was like 500,000 tons of TNT. 30 times the energy of the Hiroshima atomic bomb.
Oh, was it really 30 times? Wow.
Yes.
Oh, wow.
And yet only 5% of the energy from the 1908 Tunguska meteor over Siberia. It downed trees over 2,000 square kilometers.
Yeah, I heard of that. I don't know if I've ever seen any pictures from that, but it was essentially, it's hard to imagine 1,000, did you say 1,000 square miles of flattened trees? I mean, it was a 1,000-mile stretch or something like that, right? It was this
2,000 square kilometers.
Oh, geez. Roughly. All just flattened. I mean, that we've never seen anything like that in our lifetime. So that kind of puts it in perspective how big this was.
Yeah, this was the biggest in 100 years. Now, they think that this one was about it's 50 feet. So a lot of people were, questioning, well, how come we didn't see this? Giant meteor explodes over Russia. How come we didn't see that coming?
Yeah. How did we not see that one, huh? Well,
Yeah.
we've heard a lot of talk recently about close flying objects. So I guess people kind of just assume that we must have an eye on everything in the sky.
Oh, and goodness gracious, we do not. We track thousands of larger asteroids. There's probably about 100 million of them, about the size that this one was. About 100,000 being near enough to Earth to ever really cross our orbit. But most of these the meteorites that hit Earth tend to be on the smaller side. So when they're out in space, orbiting the sun or coming close to Earth, they only reflect about a couple % of the light that hits them. So they're small. They don't reflect much light. So it's like watching a kid across the street throw a pebble to another kid. Did you see that?
In the dark.
In the dark. No, maybe not. Now, occasionally that kid's going to throw it at you. Did you see it then? Not until it was like 6 inches away from your eye and you went, oh no.
Bonk.
Yeah, exactly. Bonk. So it's one of those times. There's only been one time where we've actually seen a asteroid before it actually went to hit the Earth. And that just happened to be pure coincidence. Somebody spotted it, 6 hours before it hit. It just there's a lot of amateur astronomers out there and a lot of different telescopes watching and trying to locate as many asteroids as they can.
Well, so like Nexstar is asking the chat room, NASA tracks these, right? But they're tracking ones of a certain size and larger that they are able to detect, right? Because if these things are hard to see in the dark and all this kind of stuff, they're only going to be able to see like the bigger ones then, right?
Yeah.
Okay.
Yes. Oh, I should have found there's a video of essentially it's, here's all the planets and then where's the asteroids that we know where they are. And it starts off a very low number. And then as we add new telescopes and things, you can see it like as the Earth drives, essentially drives by the asteroid belt with a whole bunch of new ones pop up.
Mm-hmm.
So it's as we're getting better and better telescopes and
we just see more and more
equipment, we can see more and more.
Right.
However, some of these are small.
Mm-hmm.
They are in the asteroid belt or randomly whipping around, and they are very small and they are not very bright. So it is incredibly difficult to track or even spot these. And technically this one was fairly small as it comes to these. So, it exploded. There was some damage on the ground.
Yeah, there was like about 1,000 people were injured, weren't they? And property damage too, of course.
Yeah, so a lot of it came from over 300 buildings were damaged, schools, hospitals, a zinc factory, which is one of the major things that had a partial roof collapse.
Yeah.
But mainly it was windows crashing. It was just all the windows just essentially blew out.
And doors blown open from the from the impact, right?
Yes. And so a lot of this was glass shattering and hitting people. And so many of the injuries were based on that. There's a whole bunch of it is the deep winter, as you were saying. So is it incredibly cold temperature? So there's a lot of effort going on now to try to fix as many windows as they can as quickly as possible, bringing in all sorts of different people from the region. In the meantime, people are taping up plastic and cardboard and whatever they can over their window to keep out some of the cold.
Mm-hmm.
Yes, Linux seeing percussive damage. But so it's fun. It's one of these things where you literally don't see something like this very often. This is, it's been 100 years since the last one. And even when we see, these fireballs that come along occasionally, I remember sometime within the last year, there one being over California where they were trying to track it and see.
Yeah, and I've heard there was, during the summer, there was the local Austin news chain was running a story about a bunch that were spotted over Texas. So I know that, we get them from time to time here in the States too. It's not.
Yes.
Yeah.
Oh yeah, you get them all across the world. Now, the Earth is 2/3 water.
Yeah.
So a lot of times these things will happen over water. But the fact that this one was so large and over ground made it. It has all these dash cams, so you can see all these amazing videos, and it all happened so fast. I mean, that happened, and how fast is it before it's up on YouTube and
Yeah.
I'm watching it and you're watching it and somebody in who knows where else in the world is watching it. So now they're going through and they're trying to figure out, one, gather up pieces, meteorite pieces that may have hit the ground. Because it exploded, so far the pieces that they're quote unquote finding are anything from, tiny pebbles to maybe an inch, a couple centimeters. So, and there's a whole bunch of different scientists and from all over the world trying to go in and be like, excuse me, Russia, knock, knock, knock. Can we please look at it? And so there's a whole bunch of these, random people that are going out and they're picking up, rocks that they see, or some news thing about some kids playing out in the snow, and it's like, run and say, hey, there's a hole in the snow. Dig, dig, dig. I found a rock. It's part of a meteor. Hold it in the air.
Yeah, they're already running tests on these things. They're already
yes.
Getting all the components and stuff. You were just commenting about how fast all this moves. So they are, you have all of this coverage. They're already going out and collecting the rocks. They're already running the analysis on them. I mean, it all happens within the span of, this only happened last Friday. It just blows my mind.
I forget how many hours, but within hours, people were putting things on eBay, on Craigslist, on trying to buy things that you didn't really know what it is.
Yeah, how do you know?
There's actually one, was it eBay or Craigslist listing that said, part of asteroid, buy it now. Finer print. Okay, I don't really know what this is.
There's been forever, well, not forever, but since the moonwalk, there's been fake moon rocks floating around for sale.
Yep. Yep. Now, I'm not quite sure how true it is because I haven't been able to completely verify it, but Russia has specific rules about gathering meteorites and selling them, that you're not allowed to sell them until you put them up for, analysis, specific labs, and then the lab gets a cut from whatever you sell it for.
Wow.
So I haven't been able to necessarily, back that up with actual claims that I've been able to see from
That's interesting.
Russia, but a number of different news sources actually stated that.
Huh, okay. Didn't know that.
So I'm not entirely sure how factual that is, but it is an interesting thing, and there were a number of different locals who either kind of quickly reneged on admitting that they had anything to selling anything to apparently some news station was, interviewing somebody and they kind of reneged real quickly and it's like, no. And even if I did, I don't know if I'd turn them in because I don't know if whoever I turned it into would actually admit that I gave it to them. It's like, I don't know. I don't trust the police or the local government or whatever, shake fist in there. So it's kind of interesting about how things are going along and how we will actually, how quickly as many of these pieces can be tested. There was one 20-foot, some hole, perfectly circular hole in a frozen lake.
Yeah.
And there was immediately some coverage about would that, is that a piece? Now, if it was, it would be, was it a little under a foot to 2 foot? So a little less than
it was
half a meter.
Yeah, but it was a really nice hole. And one of the
but that would be
theories...
the size of the rock that would have had to hit it to make that hole. Now, they've had a number of, scuba divers and things go down and try to find it. They haven't found any rock yet. So then there was some question about, is it really from that? Is it from something else? So
yeah, because some people think that if it hit it like that, wouldn't it have, caused quite a bit of water to kick up and break even more ice?
Yeah, it's certainly possible, and it's
who knows, right? But
yeah,
it is. That was one of the. There it is. I just found a picture of it. That is one of the ones that I saw that and I thought, that looks a little. I don't know. That's weird, but if it's a small little rock, it made a pretty big hole. That's a pretty big hole.
Coming in at a fairly fast pace too.
Yeah, that's why I think a lot of people thought it would have like caused a lot of water to, kind of blow up a little bit.
Yeah. Well, if also you think about it, a couple of these, so we've had one woman that was, quote unquote, hit by a meteorite. It banged off one or two things in her house and hit her. She ended up with a big bruise,
Ouch,
but
ouch.
there was somebody else who, a piece of satellite foaming, essentially, that as it went into orbit, some of it came down and it, hit her, and it was pretty much nothing. She didn't really know what was happening. I mean, it doesn't, by the time it gets to Earth, it has lost a lot of its energy. Now, something big enough to make that hole would come in fairly fast and smash it. But think about it, a whole bunch of these little pebbles just kind of buried themselves in the snow. I saw, one story about a decent, a small rock. I don't remember how big they said, came through some woman's roof. And then, somebody knocks on the door. Hey, can I have that? She's like, I'll give you $60. Okay. And then like 5 minutes later, something comes around. Hey, do you have one? I'll pay you, $1,500 for it. And then she's like, oh, maybe I shouldn't have sold it.
Wow.
Maybe I should have just kept it for myself.
Or just give him a rock and say, here you go.
Yeah.
Take one out of the fish tank.
Yeah. Shake it off.
Did you hear that his name was Vladimir Zernovsky, I believe, and he's the leader of the Russian Liberal Party, and he actually blamed the meteor shower on the U.S. as a secret arms test? How great is that? And he says...
oh gosh, what is that? I was reading somewhere where there is there's a network, watching for specific, explosions of a certain size, and a whole bunch of these different networks, and it's like they immediately spotted it. And there are, I believe I was kind of led to believe between the lines that there are contingency plans to make sure that it is located as, this is a meteor, this is not anyone attacking you, please do not attack us.
Yeah, no kidding, right?
We don't want a meteorite to start off World War III.
And actually, that's what I saw in some of the, like people on the street interviews that they translated. They said, well, at first we thought it was a bomb. We thought we were under attack. And you know what? Honestly, if I saw that striking through the sky and the way that thing hit, I mean, I don't think my first thought would be meteorite. I think my first thought might be drone attack. I don't know what it would be, but it'd be like some sort of, I think I would think it's some sort of attack too. Well,
how many people have seen that? You'd have to be over 100 years old to see anything this size before.
Yeah.
Now,
yeah, very true, right?
So, even then, you'd be like, I remember in my rocking, my mother rocking me, and I saw something about. No.
Yeah.
It's been a very long time since anything this large.
It's just not on the forefront of my mind. Although it probably will be a little more now.
Yes, that's one of the other things. Is now there's a huge uproar to. How come we can't see it? We need to be watching more. We need to put more money into these things.
Yeah.
There are various satellites that are looking for similar things of this nature. They're looking for rockets, and such that can be used for looking at this too. How much of a warning system can you get? Hey, everybody, you have 45 seconds to duck and cover.
Right.
And hope for the best, by the way.
We've detected a meteorite entering the atmosphere, and it should be like... Yeah, I mean, really.
Now, if this one had been iron, it would have been bye-bye town.
It was like, because it would be more dense and have a...
Yes, it wouldn't have broken apart. Yeah. It would have been one big iron chunk flung at the earth. You're throwing a rock at the dirt. Now you see the little crater that you make. Instead of, clumping together some mud and dirt and throwing it and kind of comes apart before you hit the ground. So we shall see.
Yeah.
But so now there's, a push to make other scientific data, release it, make it unclassified so that people can share. And there are a whole bunch of, military assets that are there that actually can be say, oh, yes, we see that, but we're not really allowed to tell you.
Mm-hmm. Oh.
So there's some push for that. And then it also goes back, and now we have to look back and say, all right, out of all the observations we've had, let's go backwards and see, did we see that before and we just didn't realize we saw it before?
Yeah. Yeah, that's an interesting aspect I didn't even consider.
Yeah, I mean, there's a whole bunch of data that's coming in now that, you're not going to look at. You're not going to blast through it all until, over a period of weeks. So,
Absolutely. All right. Very great. Well, thanks for the update on that, Heather, because I've been curious about that well, I guess it hasn't been all week. It's only been since Friday. But it feels like it's been a long time because everybody's been talking about it. So
yes.
now, folks, if you get struck up in a conversation where this comes up or you want to find out a little bit more for yourself, go check out Heather's awesome show notes. Tons of videos of the meteorites coming in, which is really cool to watch. She's got news stories, links, information, all kinds of things. Also, some common questions that have been asked. So check out those links. But with Heather, why don't we take a little pause right here and cover some of the picks that you've made this week? Because, well, 2 out of 3 I'm going to be buying.
Yeah.
At least 2 out of 3. All right. So first, if you out there want to help support the SciByte program, well, don't forget we have an affiliate system. Those are linked at the bottom of Jupiter Broadcasting, or if you use the extension, or if you click these links in our show notes, and we'll have our specific picks in the show notes for this week. And the first one up, Star Trek The Next Generation Season 3 is coming to Blu-ray at the end of April.
Yay.
Season 1 and 2 have been phenomenal.
Yes.
I'm really, really impressed with what they've done with this. And in both seasons, they kind of went out of their way, at least with, one particular thing that, like, is only on this set. Like, on the Season 2, it was some extended episode stuff and some restored behind-the-scenes bloopers and things like that. I don't know what it is in Season 3, but I'll tell you, if it runs $90.
Yeah.
And if $90 is too rich for your blood, they're also making just the best of both worlds available as a Blu-ray for $16. And they have a trailer out. If you're a big Next Generation fan and you remember the best of both worlds, because it was like the best season finale ever, you can watch the trailer to this sucker. It is awesome. It looks so great. They've basically made a modern day trailer out of clips from this old remastered episode of Star Trek.
Wow.
It looks like something how they would promote, like, if that episode was going to air tomorrow. I mean, it's so awesome, and it just makes you want to rewatch the whole thing all over again. And it looks incredible. They've fixed some of the sizing issues they had with the original Borg cube. They've added a ton of more interesting shots to some of the interiors to the cube. They've really cleaned up the Enterprise. The battle scenes, although they look like they belong, they're so much better looking, and they line the ships up more properly. I mean, it's really, I cannot rave about it enough. So if you only pick up one of them, get the best of both worlds. It'll be $16, and we'll have that linked in the show notes. And one last little mention here, because Heather, I think I didn't realize you were a Game of Thrones fan, but you said you were watching Season 1, right?
Gone through 1, and I'm in the middle of 2 right now.
And that's on Blu-ray. That's available right now.
Yes, it is.
This seems like a great way to go if you don't have HBO, but you're still interested in watching the show and you want to see it in high fidelity. Get it in Blu-ray.
Yeah.
Right there. So we'll have all 3 of those linked in the show notes. And if you grab those, you support the SciByte program and the Jupiter Broadcasting Network and help us keep the lights on. And you know what? I got to tell you, when you're doing shows, it's good to have lights.
Yep.
Most of the time.
Yeah.
All right, Heather, it's time for the News Bite.
Something where lights aren't necessarily needed. Dark matter.
No kidding.
I couldn't help myself. I had to go that way.
All
right. Dark matter. It's kind of the stuff that makes up for what we don't see. So the way we see things working, there has to be a certain amount of mass. We see spiral galaxies or other galaxies rotate around. Now, if it only consisted of the mass that we see, the momentum and the movement doesn't match up. So it's like there needs to be more there for it to actually rotate in the way that we see it. So we started coming up about 80 years ago. This was brought about because of that. So it's our dark matter theory, saying, all right, well, maybe there is something there that we can't see that allows the forces of gravity to hold them together. And
this always sounded like so it's hokey. It almost sounded hokey to me. Like, this is so unscientific in a way. Like, well, it almost sounded like faith in a sense. Well, we're just taking faith that there must be something there because everything else checks out. And even though we can't validate this part of the math, all this other math adds up. So this variable must exist.
Yeah, I mean, as far as we can see, there's the standard model of physics, which is sort of identifies particles and forces to kind of regulate our everyday life. But when you go on to the really large scale, the galactic scale, then what we see only makes up for, to make sense of everything, it would only make up for like 5% of the mass out there.
Huh.
So dark matter would be like 23%. Dark energy would be, which is sort of this weird force that we're putting together that kind of is driving the expansion of the universe, driving everything moving away from each other as we're accelerating. So that would be 72 to 73% of the energy in the universe. So kind of working back. And they're working towards scientific analysis of what this could be. If it was there, then maybe it's made of what they call WIMPs, weakly interacting massive particles. So these sort of particles that they're their own antimatter particle.
Huh. Oh,
so
really?
we have antimatter is real. So we have, protons and electrons, sort of anti each other. But this would be essentially when matter and antimatter meet, they annihilate each other. So if these two WIMPs collide, they would be destroyed and release another pair of particles, say an electron and a proton. I mean, the positron. So we kind of look at like, okay, so should this happen, we would see this kind of evidence. But in about 2 weeks, they're saying, there is some first paper results coming from the Alpha Magnetic Spectrometer. Ooh. It is a particle, it collects particles mounted on the outside of the space station.
Oh, wow.
And they've actually said that what's in the paper is going to bear results on dark matter. It'll be, quote, not a minor paper. That they actually rewrote it 30 times before they were satisfied enough to submit it. Now, as always with science, we must pause. Even if it's a major announcement, they still say it's going to be a, quote unquote, small step in figuring out what's there. It's not going to be the final answer, but they're thinking it's kind of moving in the right direction. So it is looking for these cosmic particles. We have different things to do that. The Large Hadron Collider looks at these. Mm-hmm. There's a South Pole Neutrino Observatory. Looks for, neutrinos. And the Alpha Magnetic Spectrometer on the space station. So these are all looking for very high energy cosmic particles. So the one on the space station actually has the ability to detect positrons and electrons that would be produced by that dark matter annihilation. And it has detected 25 billion particle events, about 8 billion electrons and positrons. So this paper is going to sort of say how many of each were found and what energies they were. So what it comes down to is if it shows an abundance of positrons at a specific energy, then that could indicate some dark matter if there's an imbalance. So you have positrons and electrons, and if there are more than one in a specific energy, then you're starting to say, well, there is something there. It matches up our theory about what this kind of dark matter would be like. Now we're kind of walking down that path. So,
fascinating.
Yeah, and then on top of that, if we see it, then it's where is it coming from? Is it comes from one specific point in space or from everywhere around us? If it's from one specific place, then maybe it's a star explosion or some other sort of, astronomical process. But if it's coming from everywhere, then that would kind of match up with dark matter as well, because that would kind of be spread evenly throughout space. So it would originate from a whole bunch of different directions. So we're saying that, okay, what's the ratio of these type of particles? Where are they coming from? And if it's a certain ratio and it's coming from all over, then it's matching up with our theories of what dark matter would be. Now, regardless of whatever the announcement actually says, is they're expecting information about it to be much clearer. So like, well, something about...
They're announcing that they're going to make that announcement.
Yeah, this is an announcement of an announcement, which science loves. It's like, hey, guys, in 2 weeks, we're going to say something possibly really cool to certain science people. And the rest of you may care too.
Well, I think that Usually, if you pre-announce an announcement, it's because you got something big.
Yeah. Now, we've had this before.
Yeah.
Where was it the Curiosity rover had their, huge, big announcement, and then they were like, oh, wait, we really did mean it was that big. We're not seeing anything crawling around on the face of Mars.
Yeah, that was interesting. I almost wonder what that was about.
It's just somebody being really excited.
I guess, yeah.
I mean,
yeah.
I can be really excited about what's in my, what was the results from my test today, and I could be like telling you, and you might think it was the greatest thing since sliced bread, and in reality, it's just something I'm really excited about.
Yeah, I follow you.
But on the other hand, we had the CERN announcement, Higgs-Bosons, a while back, where they're like, okay, we have a pretty big announcement. And it was them saying, hey, we see some evidence that goes along with the Higgs boson. It's something that's only in theory before, but a whole bunch of this data is starting to line up. And then over the course of months, and they say, yes, it keeps lining up. Yes, it keeps lining up. Things are looking more and more real. So this may be on that kind of a track where they say, hey, we have some data that's lining up in the right direction. We're going to keep checking this data, and over the course of months and years, then we may be able to narrow it down about what's going on, where it's going on. Then we'll have a better idea of, are our theories correct, or do we need a brand new theory about what dark matter may or may not be, or an alternative to it?
Well, if they come out with something pretty big that looks like they've figured a few things out, it's going to be some pretty major discoveries we've watched happen just during the run of this show.
Oh, yeah. And either way, of course, Right,
you let us know?
Yeah, I'll definitely be talking about it here.
All right. Okay. You keep us posted, Heather. With that story filed, let's move on to the What? No, we already did that. The 2-Byte news.
There we go.
Every now and then you got to prod the band. I don't know, I might fire the singers. I think the band's all right. Sometimes they play the wrong song. Those singers...
Yeah, I think the singers may have thrown the band off.
Yeah, I think it was the singers. All right, Heather. What do we got in the 2-Byte news?
All right. Lightning and headaches.
Okay.
So a new study has found that there's a 31% increase in the risk of headaches and a 28% risk of migraines for chronic headache sufferers on days that lightning strikes within about 25 miles, 40 kilometers of their house.
I couldn't tell you why, but that actually doesn't surprise me.
Yes. Now I've seen stories like this before where it's, there is an electrical storm and you can smell something or you can smell a storm coming. But this is actually says that, there is a fairly significant increase in new onset headaches. So this is the first study to actually correlate lightning in the associated weather to what's happening in our heads. Now, do they know exactly how? No, not really. There are a couple of ideas that they have.
Okay.
That are electromagnetic waves emitted from lightning could actually help trigger headaches. Or perhaps something in the lightning process increases air pollutants or the ozone and fungal spores or some combination of events in the atmosphere itself that could help trigger migraines and headaches as well. So they have the scientific evidence to say so. Now they've got to figure out a study to figure out why and the how.
That's really fascinating. I wonder if it could be like maybe like a pressure thing. I don't know. Like, is there like a
combination of what how the storm is set up to allow lightning? Is there the pressure, the ozone, the charges,
right?
Or what does lightning actually do? Does it affect the atmosphere in some other way that triggers things? Or
you almost have to believe it's a combination of multiple things.
Oh, it's got to be a combination of a variety of different things.
So, speaking of meteorites and things like that, we had that big asteroid flyby on the 15th.
Yes, on the same day.
But they were unrelated.
Completely and totally unrelated.
Big Boy didn't bring like a couple little friends with him, and they
came from completely different directions. They tweeted on that day. I was like, the only thing they have in common is I'll talk about them on SciByte. That's it. That's what I typed, literally, not word for word, but yes, I was like, the only thing they have in common, SciByte.
I mean, that really, that's a pretty big coincidence, actually.
Yes, which is, it was kind of fortuitous in the fact that everyone freaked out.
It kind of reminds you how we really have just like, who knows? Who knows what's going to happen anytime? Because we go 100 years without anything like that, and then all of a sudden we have this huge flyby and then on that same day we also get struck. So we had two different rocks coming at us at the same time.
Yeah. Now, that was, the closest approach to an object that size. It was about roughly half a football field across. So
That's a big rock.
Yeah. Now, some people worried about the space station because it came, I think, very close or inside the orbit of the space station.
Ooh.
Now, it didn't pose no danger to
close.
Yeah, it posed no danger to them. They didn't even have a chance to observe it. In fact, no NASA space station assets were actually making measures of it because it was moving so fast. It was, somebody throws a rock by, 4 or 5 inches away from your head. You're not going to really bother trying to take a picture of that with your camera.
Mm-hmm.
You're like, nope, very unlikely I'm going to catch that one.
Mm-hmm.
So there was a lot of ground instruments trying to take pictures of it. There were a number of people. There is a radar observation that actually I just saw the video that it came out today. So they had, the radar was planning to take images for about 8 hours after the flyby as well from a antenna in California Mojave Desert.
Kind of looks like a potato.
Most asteroids are potato-ish.
Yeah.
A
I just wish
very,
we could go up
very
there
large chunk are potato, quasi, scary, mutated potato shapes.
Right. Killer potato from space shape.
Yes.
Yeah. I just wish we could go up there and land on it. I mean, maybe not this one because it was going so fast, but one of these days would be great to. And I know some of the Google guys are working on a project to do this, but to go up there and not as part of Google, it's one of their own ventures to land on one of those things would be so cool.
Yeah, well, there's been a number of talk in the last few years about asteroid mining. I believe I've talked about, 1 or 2 different ventures on this show, actually, that say, hey, we have an idea, let's go out, let's mine something on there. Now, theoretically, that would be something more with a more stable orbit and not shooting by us, like going far, far, far too fast for us to really feel comfortable, that I would feel comfortable trying to land anything on that right now. But those people came out again and said, hey, they kind of gave an estimate of, hey, we think it was made of this. It would have been worth this many dollars, this many millions of dollars or thousands of dollars. And so, hey, we really need to go out there and do this stuff because they're right here. They're whizzing right behind us, in front of us, and smacking into us now. But it gives you a really big idea of there are a lot of asteroids out there. They are going all about space, all around us, near us.
They could be, so what Heather's trying to say without sounding down about it is make the best of what you got now. Because there's a lot of rocks out there. And, thankfully...
There are people tirelessly looking for these things. Right. You will never know. They're in some observatory, with a bunch of their friends. And their whole plan is to find as many asteroids as they can. And that's their free time.
And so far, the worst that happens is we get to talk about them here on SciByte. Well, and if you're in Russia, some people got banged up. But
yeah,
I mean,
you have to buy a new window. There's part of a factory that got collapsed.
But the upside is we talked about it on SciByte, right? Yeah.
Yeah, I feel bad and being all happy about it now.
Okay, all right. Why don't we move on to some viewer feedback to get away from that?
Okay.
All right, what do we got?
All right. This is actually one of those strange weeks where I get 2 people writing in about nearly the same thing.
I like that.
Yes. I have Jason Null, who is asking me what kind of a program or software that has sort of a virtual model of the Earth and the Moon to kind of get a better idea of, how they're interacting and all that kind of thing.
Wow.
So actually I found a handful of free Java simulators online. They kind of give you a head start at least.
Oh, wow. That's neat.
So it's like a little sphere, stick figure sphere. And you can say, sliding bars back and forth saying what kind of a day, what part of the day, what type of, what part of the moon phase, sort of rolling through these to give you an idea of what their paths actually are.
Yeah.
And there's, two that I put up there. Another one that actually you can sort of dial into your latitude. And it'll kind of tilt, tilt the sun's orbit, that plane sort of closer to where you actually are.
So these are really neat. So now I know what I'm going to be doing after the show. I'm playing with both of these.
Yeah, there were a number of them that I found, but those two were kind of the niftiest of the bunch. So go on, and somebody else actually asked as well, where they mentioned that they were in Sweden, and they said they seemed to see the moon up in the sky. Jason, oh goodness, I pasted the wrong name again. Sort of asking, I see the moon up in the sky a lot. Is it just because I'm in Sweden? Am I just catching it in the right time of day?
Yeah.
So you kind of dial in to that one simulator, kind of bring it up to a higher latitude, which essentially means, if you think about it, the higher altitude you have, the sort of longer days and longer nights you have. It's because the moon and the sun, their orbit is a sphere. It's like a hula hoop around the Earth. So they're going to follow the same path. It's just that the moon moves at a very different rate than the sun. So it orbits much slower. So it takes a long time for them to sort of match up again and give us a solar eclipse.
Mm-hmm.
So you can kind of see that and say, when you're at a very high altitude, then the sun and the moon are much lower. Essentially, if you're on the North Pole, the sun is always on the horizon type thing. So if you're most of the way up there, if you're at, Sweden is 65 to 75-ish degrees north latitude. So it's very high. So you'll have the sun and the moon on a very low tilt to the horizon. So if the sun's going to be up for a very long time, it gives the moon a chance to be up that long as well. And I mean, if you think about it, you step back, you're out at night, you don't see the moon. Then the moon rises at, 9, 10 p.m. or whatever it is. It's rising because it just set for somebody on the daytime side.
Mm-hmm.
Somebody else is going to work and they say they see the moon setting. Then you see the moon rising. So it could just be a lot of fortuitous luck that you happen to see the moon up a lot, and it could be
because you live on a mountain. Maybe you live on a mountain. I don't know.
You're not climbing a mountain to see the moon.
Oh. I mean, if I don't climb, so I can't climb like all the way to the top of a mountain and sit out of the atmosphere and look at the moon? Because I've seen, oh, dang it, that ruins my travel plans for the summer, Heather.
Okay, you certainly climb a mountain and see the moon, but your ability, well, if you breathe, that's good. So you're able to breathe.
I was making a joke that I could climb outside the atmosphere just by going really high on a mountain. That's all.
Yeah, that's where I was kind of looping back around too. Is if you could breathe, that would be handy. If you can't breathe, you're not going to be seeing much of the moon.
No, oh, good point. Good point.
Yeah, sorry about that.
All right, well, you can email the show, SciByte at jupiterbroadcasting.com, or hit that contact link and submit a little form when you select SciByte from the dropdown. And it goes right into the SciByte inbox. Hey, Heather, guess what?
Yes.
We got some stories that have leveled up with some updates.
That's right. Mentioned earlier, CERN, the Higgs-Boson, the Giant Hadron Collider. This was the instrument that gave us all the Higgs-Boson news. And, there was some talk of, yes, we need to get these measurements in, get all the readings, get all the data, because we are going down for
I remember
upgrades.
that. Yep, I remember you talking about that.
Now, just 7 months after the big announcement, they are now 99.9% certain that what they see is the Higgs boson, but now needs to go down for an 18-month period upgrade.
Oh, geez. Right now?
Yes.
Well, I want to know about the Higgs boson.
Well, we're pretty sure, and the actual upgrades will boost the energy capacity that we're able to see, and that will actually be really essential to confirm that the boson that it sees is the Higgs boson.
Well,
so it'll allow us to probe new dimensions of physics and science to see what else is there, give us a better idea of the particle that we are seeing. So it goes down about every 3 years. they bring it down, they give it some upgrades, then they go back.
That makes sense.
And really, they have a lot of information to go through. The data from the last 3 years, it's going to take them at least a year to try to go through all that stuff.
Great point.
So they're down for 18 months, but that is just new measurements coming in. It gives them a chance to catch up on everything that's been going on. So it's like you're cramming for a test, you have this really busy class, and now you're going to be down for a little while, but you have a lot of homework that you need to go back and do.
Well,
a lot of reading that you need to do.
Do you think it's possible that we would get some sort of news announcement during that time, since they'd be going through the data?
Oh, it's certainly possible.
Huh.
I mean, you go through and, it's always the data in the data we talk about in astronomy sometimes, where they go back and they say, hey, actually, we see that these type of stars are doing this, or we see that this star is actually blinking. We think there's a planet there. So now a great deal of the data that will come out might not be as interesting to everyone. Now, the big thing was the Higgs-Boson.
Yeah.
So a lot of that data was being chugged through pretty quick.
Right.
They're going to be able to go back and look at some more data and be like, yes, we're even more sure and happy and joyful and have our party hats on. Now, a lot of the other data that might be there, a lot of people might not care so much about. It's not going to be top story news events.
Yeah, you're probably right.
But
interesting to them, probably not so interesting to the general public.
Yeah, I mean, might be interesting to me, but nothing as big history textbook as the Higgs-Boson, most likely. So I've been increasing the voltages that we were able to see, 7 tera-electron volts, 8 tera-electron volts. Now it'll be, by the time we get back to 2015, it'll be up to 13 or 14. So, and that'll run to 3 or 4 years, and then they'll bring it down for 18 months and give more upgrades. So that's kind of the rotation that happens.
Very good. All right, Heather, then let's swing in to a spacecraft update. Now, this one was breaking today, wasn't it? I think I heard of this around, in the morning time today.
Yes, actually, I heard it on the radio coming home, and I went, came home, search, find a story or two, paste it in the show doc, because guess what? We couldn't call the space station for 3 hours this morning.
Yeah, NASA officially lost contact with the space station for a little while.
Yes, it was. All they were doing is they were upgrading some software. So they're in the process of updating the station's command and control software and transitioning from the primary computer to the backup computer and doing a software load.
I see.
And
blame the IT guy. Blame it on IT. I see.
Yep, sorry. They totally blamed it on IT. Super blamed it on IT.
And actually, one thing that I guess that was kind of interesting is they maintained contact with an outpost in Russia.
Yes, they're actually able to essentially call up Russia, and when it was in the skies above Russia,
right,
then they're able to make a call up and say, hey guys, plug in the backup, quick.
Well, we gotta go right back. And then they would come back around. Okay, guys, did you plug it? And they go back around again. Yeah, so tensions were high. It was actually one of the lead stories on Wolf Blitzer's Situation Room this morning when he went on the air.
Yeah, and I think the first message back from the space station was essentially, "Hey guys, everything's fine. We're fine. we're just doing our morning routine."
They're like, actually, it was kind of nice not to be bothered. We got a lot of work done this morning.
Really, we kind of noticed partway through the morning, man, we got a lot of work done. Why? Oh, nobody's called. Nobody's called for a little while.
Those are my most productive mornings myself, so I can only imagine that's how it is even up in space.
Yeah.
All right, Heather. Well, now that we're up in space, why don't we go over to Mars and do a Curiosity update?
Go.
And liftoff of the Atlas V with Curiosity.
Touchdown confirmed. We're safe on Mars.
All right. So what's the rover up to?
Alrighty, we've been talking about it drilling into rocks the last couple of weeks.
Yeah.
It is the first rover, as you may have heard me say, that has actually been able to drill into something.
Mm-hmm.
Drill down about 2 inches. So we're able to see all the dust in the interior of this rock that came up. Now, what's interesting is that it's very gray. It's a very different color from the outside of the rock.
Huh.
So that definitely tells us that there is a combination of some sort of weathering on the outside, or there's different material looking back in history essentially into the depths of the rock, but there is very different things going on. So they were able to go through and shoot their lasers.
Ooh.
Yes, and take the ChemCam to do spectrographic analysis. Do it of the rock face, do it of the piles of dust around it to kind of give the fresh rock powder to kind of get a better idea of what's going on quickly.
Right.
So in the coming weeks, next couple weeks, they're going to try to do more with this hole. They're going to try to collect some of that gray powder to bring it onto some of the onboard instrumentation, get a better idea of exactly what's going on, what's the difference between the interior and the exterior.
Get down to the bottom of those rocks by drilling into them.
Yes.
Well, I would be curious to see what they find out, especially when you come on here and tell me they have found signs of bacteria and maybe old fish skeletons.
You keep looking for that.
Okay. All right. Well,
it might be a little while.
In the meantime, you know what I'm going to do?
What?
I'm going to jump in the time machine. You ready to go?
All right, hold on.
All
okay,
right.
I'm in.
Here we go.
Okay.
Buckle up this time.
I did. You almost left me. Scary.
Yeah, I even installed these handles here, but we didn't really need them for going to 51 years ago. So this takes us to February 20th, 1962. Heather, what happened this week in science?
John Glenn piloted the Mercury Atlas 6 Friendship 7 spacecraft on the first U.S. manned orbital mission. Now, the actual first just plain manned orbital mission was Yuri Gagarin in April of 1961.
Right. Yeah.
But the U.S. got there in February 1962.
Not bad. February 1962 was, they were, what was it? So did we go to the moon the first time in 69? Is
Yes.
that right? So they were working towards it at an amazing pace back then, inventing it as they went, which is incredible if you think about it.
Yep. We did 3 orbits around the Earth. 17,500 miles per hour.
Wow.
Actually saw, what I found was interesting as I read here was when he spotted Perth, Australia, all the city's residents had gathered together and they switched on and off their house lights, like everybody in unison.
Oh, Perth is so cool.
So that's how they greeted him. They're like, off, on, off,
Wonder
on.
how did they do that in 1962? The phone, maybe, I guess? The radio. It must have been over the radio or the TV. Maybe it was over like a broadcast. It had to have been
radio.
Yeah.
And then at a certain point, when he doesn't have a radio, can see the lights flashing in town. Be like, oh, I want to join in.
Were people able to communicate before the internet? I'm not sure how that works, to be honest with you, Heather. So
I think they were.
Okay, all right. I'm not sure. Well, that's amazing. Wow, it's 51 years ago. That's really actually not that long ago that we were doing that.
Yep.
All right, well, now let's recalibrate the SciByte 2000 and look up into the sky this week.
Alrighty. Kind of a quiet week in the astronomy looking up this week. We've got in the early twilight, look to the west and southwest. The brightest object in that part of the sky is going to be Mercury. Now, Mars is getting kind of harder to see as it gets farther and farther into the sunset. So, but if you look farther to Mercury's lower right, you might be able to see it. Now, Jupiter is starting in the south at dusk, moving to the southwest, and then setting around 1 to 2 a.m. And Saturn, about 11 to 12 p.m. local time, is going to be moving in the high southern skies, moving towards, by the time dawn gets around, it'll be closer to that direction. So, got Mercury in the early twilight, Jupiter at dusk, Saturn 11 to 12 p.m. Your local time. So, got a couple planets up.
Oh, that's not so bad. Just like, meh, planets in the sky, whatevs. I don't like them.
You know,
whatevs.
they're up there a lot.
All right, Heather. Well, great show. And don't forget that you can always find out when SciByte's live by going over to jupiterbroadcasting.com/calendar. We have all the shows live and release schedules there. There's also, this might be the trick if you want to try to join us live more frequently because we're always looking for more live viewers. Add that Google Calendar to your Google Calendar. and then it'll just put it on there to your time zone, but we also have a time zone converter link underneath the calendar to put that in your local time. That way you can join us over at jblive.tv. It is 7:30 p.m. Pacific, or download the show every Wednesday morning over at jupiterbroadcasting.com. All right, Heather, well, thank you for the great show.
Thank you.
And thank you to the chat room for joining us, and thank you everyone out there for downloading us, and we'll see you right back here next week.